Okay, let's do some more math. Let's look at divided doses and weight-based calculations. In this problem, we have a child that weighs 15 kilograms and is prescribed a medication with a dose of 2 milligrams per kilogram per day in equal doses every 4 hours. Available is 10 milligrams per 1 ml. How many mLs will you give per dose? I'm going to show you two different ways on how to complete this problem. The first one puts everything in the problem into dimensional analysis. So to begin, we're going to use the Waco to help us remember what to do. Okay, so what do I want to give? What units do I want? And that would be mLs. I'm going to put that on the left there, and I'm going to put it on my numerator. And I'm going to look at my problem. So now I want to see what is available in my problem, and I have 1 ml is equal to 10 milligrams. Okay, now I'm looking at conversions. I don't really have any conversions to do because everything is in milligrams, but I do have to put in this dose here in my problem. So I'm going to put 2 milligrams at the top. Okay. And it is per kilogram per day. So I'm going to put my kilograms down here per day. Kilograms per day. My patient weighs 15 kilograms. And let me cross out here and see what I've got so far. Okay, doing good, but I don't want my problem is not per day, it's per dose. So I need to convert that day into hours. So 1 day is 24 hours, and I'm giving it every 4. Okay, so I can cross that out. So everything is crossed out. So my math should be good. So when you multiply across, you get 15 times 2 is 30 over 240. And that gives you 0.5 mLs per dose. All right, so that was method number 1. The second way we can look at this is doing it differently by taking our weight. And notice our weight is in kilograms already. If it was in pounds, we'd have to convert that. But let's just figure out what our dose is. Ordered. I'm going to figure out what's ordered. So what's ordered is 2 milligrams per kilogram. My patient weighs 15 kilograms per day. Okay, so 15 times 2 is 30. So my order is for 30 milligrams for the whole day. Now I'm going to start doing my dimensional analysis problem. Okay, now I don't have to put all this stuff in here. All right, so I'm going to start with what I want. I want mLs. 1 ml is 10 milligrams. And then I have an order. What's available? What's my order? My order is 30 because I just did that math to make it easy. But it's 30 per day. And I got to do my day up here. And 24 hours. 4 hours. Okay. And then can I cross everything out? Yup. And I'm left with the same, just ml. And that will also equal 0.5 mLs per dose. So you can do it either way. It doesn't really matter. You can do it where you do the order, figure out your complete order first, or you can just plug it into your problem if that suits you better. As long as you're consistent with how you do it, I'd pick one method and stick with it. That way you don't get confused on any other problems. Let's look at this one. So we have a 12-kilogram child that has a medication ordered for 2.5 milligrams per kilograms per day with 3 doses per day. They're going to get 3 doses per day. How many milligrams would you administer per dose? So this one's asking just for milligrams. How many milligrams per dose are you going to give? So if we're going to start with what we want, and what we want is milligrams because that's what that question wants us to find out. Put that on top. Okay, what is available? 2.5 milligrams per kilogram per day. Okay, and how much does the child weigh? We have a 12-kilogram child. All right, and we are going to give 3 doses. So in one day, I'm given 3 doses. Let's check. Day. I'm going to, here it is, milligrams per dose. So let's do some math. So 12 times 2.5 is 30, and divided by 3, and that equals 10 milligrams per dose. All right, let's do it the other way that we talked about before. So we're going to do milligrams, right? That's what we want. Now here we are going to go ahead and look up at the top here, and we're taking a look at our kilograms in milligrams per kilograms per day. So we're going to go ahead and take our milligrams per kilogram. The child weighs 12 per day, and that's going to be what is ordered. So 2.5 times 12 is 30. Okay, so 30 milligrams. And up here, we have 30 milligrams per day. We have one day. We're given 3 doses. 30 divided by 3 is 10 milligrams. Let's just make sure that we have everything crossed out. Yep, and we're left with, milligrams per dose. I didn't mean to do that to the milligrams. Okay, so it's the same answer. It's just pick a method and stick with it. All right, let's do this one. So we have a patient that is getting 2 grams per day in 2 divided doses of a medication. It comes in 250 per 1 ml. How much will the nurse give per dose? We're going to start with what we want. We want milliliters. Put that on top. What's available? Well, we have 1 ml that equals 250 milligrams goes with it. Any conversions? Yes, because we have grams up here and it comes in milligrams. So we've got to convert that. So I'm going to put milligrams here to grams. That's where I'm going. So 1,000 milligrams is 1 gram. My order is 2 grams per day. That goes with it. but the order also says that it's going to be divided into 2 doses. So one day I'm going to give 2 doses. All right, so let's check things off and make sure we're on the right track. So day, grams, grams, milligrams, milligrams. I'm left with mLs per dose, which is what I'm looking for. So here we have 2,000 multiply across the top, multiply across the bottom would be 250 times 2, 500. There we go, 500. 2,000 divided by 500 is 4 milliliters per dose.